going to start now. There are already several participants, and some of are still joining. But we'll let them join in and we'll start the session. I hope you all can see my screen.
Yeah.
Yes, sir.
Okay. So this session is basically onto the not onto the very basic level of the monitoring to know what is the monitoring part, but a sort of an advanced and field level concerns that we normally come up with the monitoring solutions, how it can be better utilized, what should be things that we really should look upon when we talk about monitoring. So I'll just start with the basic. So as you have seen just a small slide in the introduction, just to introduce you verbally as well. Webdyn is basically a company initiated in the year 2000, and it's been over 19 years now since we are into the field of machine communications for various sectors, specifically, namely energy, industry, smart metering, transport, smart grid, smart cities. Wherever you see the machine-to-machine communications, maybe wired or wireless topologies, or the need of the remote monitorings or the IoT requirements. In every sector, the Webdyn is available with the on-the-shelf and specifically to be designed off-the-shelf products. Webdyn is a proud member. Hello. Hello. Can you please all the participants can you please mute? And here I'm not getting the link to mute everyone in the WebEx. It was in Zoom, so I request all of you to please mute yourself for some time until unless you have your queries. You can ask the queries during the transition of the slides. Whenever you have any question on any particular slide, you can ask, and then again you can mute yourself. So Webdyn is a proud member of LoRa Alliance and Powerline Communication G3 Alliance for different protocols of the communications, wired and wireless. The question is like remote monitoring for solar PV plants, why it is needed. It was a question like, almost like 4 to 5 years back now, but it's not the question why it is needed, but the question is that, is it really mandatory even for these small plants? But the answer is yes. Why? Because as most of the solar PV plants are installed in remote locations, as we all know, and the O&M, even if it is a 10 kilowatt plant or a 1 megawatt plant, the O&M is a real challenge. And for that purposes, we always need to rely on the reliable data source that can help us in the remote analytics.
Yeah. Excuse me, Gurudji. Hello, Gurudji.
Hello.
Better all are put in mute, then only start the program. Yeah.
That's what I'm requesting everyone, but I don't know because I'm not getting any option to mute everyone. I'm sure it was in Zoom, but not in WebEx.
Gurdeep ji, if you go to participants, you will see option mute all.
No, but in the participants, I'm only getting the list, not the option.
Please mute yourself.
That's why I'm requesting everyone to mute themselves by their systems. Okay, I think it's done. Now mute all. Fine. So I think now it's time to continue. Okay, so the reason is that it's not like we need the monitoring for the bigger plants, or we don't need the monitoring for the smaller plants. Smaller plants are equally important because they are also the plants which are mostly located in the remote areas, where and the O&M of them is also needed, and it needs to be maintained for the same age of 25 years as the bigger plants. And that's why you need to rely on to the most reliable data source, and as well as the detailed analytics. The question is that why Webdyn? If when you have several hundreds of choices to go for the monitoring levels, you have inverter-based monitoring which comes up as free instead. Although there is nothing like free, even though when we are breathing, it's not free. It's the air today is contaminated, filled with viruses. We all need to spend a lot in the sanitizations, hygiene, mask, and every time. It's just not the matter of when the COVID is spreading, but in normal cases as well. So free generally comes up with several issues, several concerns. So ultimately, in the end, it's not free. Then what is the proper way to select a sort of a monitoring? Why Webdyn? How Webdyn can support? So first point is the expertise that comes up with the expert level. We design our own concentrators, and we are the masters in this field and the global leaders since last 19 years. The customer relations, globally over 1100 customers in the solar sector only, and overall if I'll talk about India, Middle East, and a few of the Asian countries, there are almost like 165 satisfied customers. For small rooftops and PV rooftops and small scale utilities. Like that's the data which has just covered up in past 3 years. So that's what is the confidence on the products. If the flexibility and quality, that's played a very vital and the crucial role when you select any particular device, starting from for any particular application. The flexibility has to be there, and moreover that the quality. So when you talk about data loggers, we normally don't see these components. We tend to ignore these components most of the time, which is mostly the quality levels. Webdyn data loggers tends to follow and vigorously follow these standards as at minimum, which are CE, UL, ROHS for safety, RED, REACH, radio and technology directives, EMC, EMI, low voltage directives, and there are several more which we tend to follow. And the flexibility is that you don't have the models to select from for each and every particular capacity or the range of the capacities of the plants. So you have a single model, you have ease of selectivity, you just put it on any capacity of the site and it starts working. So there is no limitation at the product levels as well. So it gives you full flexibility and the quality. Further, I'll expand the flexibility components when we'll transit across the slides. Then comes up the price positioning. We used to have a fear when we are talking about the quality and flexibility, then we might be talking about some very high or bigger prices, which might be not in our vicinity or might be out of our budgets or the pockets. It's nothing like that because the prices are very well proportioned, very well balanced. Very well balanced, and the ratio is quite good. We never say that the prices are too low, or we never say the prices are just exorbitant. So the reason is that the initial pricing could be at a particular level, but when you talk about the running cost within few months, the management, the O&M cost, it gives you a very quick return on investment in a couple of months time. Just give me a second. Okay. So that's the price positioning, which is very well balanced. And then, as I mentioned, that it's the one device which can be utilized for several sites, sites having different brand of inverters, meters, sensors, or even a single site having different brand of inverters on a same site. That site might be an extension of one project to another, or that site might have two different brands or two different buildings having two different inverters or meter makes or sensor makes. So there is no need to worry about that, because you can merge all your field devices in a single data concentrator yet, which is on Webdyn. So that's why it's one for everyone as well, and really meant for heterogeneous applications. We not only talk about the standards and quality, we really show them. We have these particular standards that we really follow vigorously for the electrical safety as well, for the radio tests as well, for EMC, EMI tests as well, and several other tests that are mandatory as per the European and US standards to follow. What are the Webdyn range of products for the Indian and Asian market specifically? Those are Webdyn Sun, which is the prime data concentrator, mostly utilized for the solar rooftop PV monitoring, ranging from a few kilowatts till few megawatts. Similarly, then there is Webdyn Sun PM, which is a new controller and come Datalogger, which I'll say. It's most versatile, advanced form of Webdyn Sun with the controlling facility inbuilt that can manage the DG-PV synchronizations and also zero power export. And in addition to the controlling feature, it is having the advanced monitoring features as well. The advanced monitoring features as well, which keeps on, which provides you several added benefits, which we'll explain in the future slides. Then Webdyn Modbus. Webdyn Modbus is just a sort of a subset of Webdyn Sun with limited functionality of Modbus devices that you can communicate. The USP is that there is no limitation to the Modbus devices practically, as you can have in mix of as many number of devices, for example, up to 200 to 247 devices in a single chain. The limitation will be there of the chain or of the daisy chain. That will be there, and again that will come in the next chapters. Then the weather sensors. There are sensors which are being designed by Webdyn. There are sensors which are in the specific partnerships with the European and Japanese companies for pyranometers, for temperature sensors, and for pressure sensors, rain gauges, like that. Enclosures, sometimes the enclosures like IP65 polycarbonate are needed for the data concentrators, so that there should not be any data loss when we are using SIM cards for internet or GPRS connectivity. For that, it's always recommended to install or to mount the data loggers in a polycarbonate or ABS enclosures. So if you have them on your sites, it's better to mount them because they are DIN rail mounted. If you don't have, then we can provide you them with the enclosures and SPDs. Then Webdyn RF, meant for the long-range wireless network connectivity, which may range from 10 kilometers to 20 kilometers of wireless data collection and transmission. Then Webdyn Grid, which is mostly meant for the street light management, charging stations monitoring in terms of EV, and the Wi-Fi modules that normally, when you have a small project, but you have multiple buildings, for example, a university or a college or a school, and you have, for example, a 200 or 300 kilowatt project, but you have 5, 6, or 7 buildings. Sometimes it may not be commercially viable to always put the data loggers on each and every building instead. So it's better sometimes to put up a centralized data logger on one building and to put the modules on remaining of the buildings, so that the data from those buildings can be transmitted wirelessly towards the central building. Now, coming on to the real scene of this event, that first of all, to understand what are the O&M challenges that we tend to see in our daily operations apart from the regular data collection. So what are the challenges? So I have tried to sum up the challenges in 10 parts, starting from the panel side till the data communication side. So the first point is the panel cleanings, which is mandatory to see, but what we do is we always tend to schedule the cleaning times, that every week or every 15 days or every alternate day, depending on to the location where we have installed our solar, and the importance of that solar. Again, it comes up with the capacities normally. But as I say, we are not tend to capacities. We always treat even the lowest capacity of the solar as of the utmost importance, as we used to see the megawatt levels. So panel cleaning is the foremost importance, because this is the one which you can only feel when you see that your production is falling, but you don't have any clear reason why. Second issue could be your MPPT failure, or MPPTs and inverters underperforming, or the inverter related statuses or fault codes or alarms, or the communication failures between inverters and field devices to the data logger, or the sensors related concerns, or the weather related concerns, or the grid unavailability. Sometimes when you don't get the data on the web servers, there used to be mainly two issues. Either the network is not there on the site in the data logger for the data logger to transmit, or the grid is not there for the data logger to power on. In Webdyn's particular models, Webdyn Sun, Webdyn Sun PM, we used to have some inbuilt battery which plays a very crucial role when there is no grid availability. The purpose of those batteries is to raise an alert, an SOS alert on the clouds, on the servers, that there is no power. So it will raise an alert of power off. Similarly, an alert of power on. So basically, you can have a trace of the grid unavailability time and date. Similarly, the internet issues, whenever there is an internet issue, it used to have its own memory to keep the data safe and stored until unless there is a network availability. Once the network is available, the stored data is transferred on the cloud in the form of last in and first out. So the latest information comes at the top, and then subsequently the previous informations. Then the internet issues, if there are any internet issues, or the sensor failures, or the meter related concerns. So these are the main concerns. Meter tampering could be like someone has changed the meter, someone has tried to do some issues, some malfunctioning of the meter to safeguard the readings or to reduce the bills. So basically, you can come up with all those challenges and can easily tackle these 10 named challenges. There could be even more, but I've tried to sum up the main challenges that you tend to see in the fields. When you come to the analytics, what normally you see, normally this graph seems to be okay, power is there, radiation is there, but this graph is going to tell you some crucial facts about your plant's conformation. What it is telling instead, that if you will see at the same time the inverter levels information, that inverters has gone to zero. They have tripped to zero several times from the morning time to the evening time. There are several inverters. There could be several reasons for this to go to zero. Maybe grid fluctuations, maybe the frequency fluctuations that tends to put the inverters on a standby mode and then on generation mode. There could be active switching and non-switching, or maybe some harmonic distortions. So this really needs to be checked at the inverter levels, why it is happening, what could be the purpose. Normally what happens is these queries comes to the data logger companies or to the monitoring portal companies that I'm getting this tip. But this is not the role of a data logger company. Data logger can show you what's happening, but data logger cannot tell you why it is happening. Web portal can give you deeper analytics, but then with those analytics, the purpose is to check at the site level that why is it happening? Is my power fluctuating? Is my frequency of the grid power not stable? Is my particular inverter having some sort of trouble? Or why these particular inverters are dipping again and again? Similar sort of challenge, for example, when we are reading the string level informations from particular inverters, and then a particular current of the string is showing a sort of a peak at the daytime and at the evening time. For the normal functioning, it's okay. This could be a reason of the certain spikes. These spikes can be for numerous reasons. Could be for improper wiring, improper earthing, improper grounding, maybe Modbus communication issue from the inverter sides in the morning, or when they are starting up, they are reaching to their peak. By the time they are generating some spikes, So this needs to be corrected at the field levels, but this gives you a very good idea that this is what is the trouble that is happening at your site, which you really need to take care of. These troubles, which I was talking about, like these or these spikes or the surges or the damages, these trouble used to there is a big reason behind this. Of course, which could be EMI, EMC interferences, which could be the surge inductions, which could be the loose connections, which might be creating unwanted spikes. But then there is another, most important reason behind this, which we really used to, ignore when it comes to communication part, which is grounding. And I'm going to cover this grounding part specifically in this session as well, because even though I'm not saying the customers, but we as a data logger companies, we normally don't tell customers or don't guide them that how the grounding needs to be done, because we always believe that customers are good, they are more knowledgeable, then they know grounding is a very common part. But I have seen that there has been several cases that have come up, and the issues that have come up because of the grounding. So I've thought of to bring it in this session. Just take an example, maybe your sensor or any of your field device I've taken up as a pyranometer, connected on one of the as a data plus and data minus points of the data logger. There is no grounding, nothing being done. This pyranometer is, you can treat it as a CMP 11, let's say this Kippenzunen sort of a secondary standard pyranometer, having a voltage range of 250 millivolts, which we called as input limit. This means that whenever we are reading, the maximum to maximum value that can go for the pyranometer based on to the actual conditions will be 200 millivolts based on to the maximum peak. There are two words in this segment, which is input limit and the common mode range. So ideally, common mode range is the voltage that used to occur between the data logger terminal and the device's communication terminal, whereas the input limit is the voltage that tends to happen between the two measurement terminals of the data plus and data minus of the field devices. So ideally, if I'm checking up the voltage between this terminal of the field device and the data logger ground, it should show me the maximum value, which is 200 to 250 millivolts. But what it is showing me 4.1 volts, which is quite higher than what it is designed for. Then from where it has occurred. There is no voltage source additionally in this. This we'll see how it has come up. If you will see in this figure, the thermopile pyranometer is having the input voltage, which I've explained, of 250 millivolts. That means the maximum voltage difference it can measure between two terminals is 250. This should be 250 millivolts. And the pyranometer is not connected to the data logger ground anyway. You will see there is no link. This means that the floating voltage, which we term as the floating, so the common mode range can be exceeded. This voltage is common mode range because the potential difference between the pyranometer and the data logger ground can float. So this is called floating voltage, which is occurring between the pyranometer and the data logger ground. Further, this can be the reason because of the atmospheric conditions, electromagnetic inductions, electromagnetic fields that can cause the voltage between the sensor and data logger of several volts. It can be of 5 volts, it can be of 10 volts as well. And when it can be 10 volts, when it can be 12 volts, it can easily damage some sort of electronic components inside or even a microprocessor, which are tend to work onto some 1 or 3 volts maximum. So to make this problem particularly tricky, this often does not happen immediately. Sometimes we say, okay, we have connected the sensors, we have seen the data, we have checked, it's working. But normally this problem tends to take some time. As I've mentioned, it's atmospheric conditions, it's EMI conditions. It might happen during rainy season. It might happen when the lightnings are occurring. It might happen, when there are some sort of electromagnetic fields. Maybe the high voltage cables are flowing over, or maybe the power supplies are laying, these communication cables are laying very near to the power cables. That sort of electromagnetic fields that may create over a period of time then these problems can come. So how to overcome these issues? It's quite simple. Now you will see there is only one difference. We have tried to connect the ground with the Datalogger ground. With this, you will see that the floating voltage for the sensor to Datalogger has gone down to 0, which is very good. But there has been another issue, which is now the Datalogger floating voltage. The floating voltage of the Datalogger has been created, which is almost of the level of 100 volts, which cannot be understood when it comes to a communication, but it is there. Now this can destroy every communication part in the chain. The data loggers might be the sensors as well, or some communication cards as well. But where it comes from? It comes from the same floating issues. Again, how to overcome this issue as well so that everything can be safeguarded. For this, if you will see, we have to make a grounding of sensors to the data logger, and then a data logger to a physical ground. This could be the DC ground specifically. And when you will see now the voltages between the data logger ground and the real ground, it's 0. Between the sensors to the data logger ground, it's 0, which means it's a perfect wiring example of the field devices with the data logger, which can work for years and years safely and accurately. This is what in the real practice we have to follow, but we never follow this thing. We never follow, because in our data loggers we have this link inbuilt so that you don't need to make these links. But obviously on the data loggers you have to have this link available on the side. There are always the grounding points available in the loggers which you need to connect on the physical ground. And this ground could be the DC ground, not the AC ground, because again, AC grounds have different potentials due to several different devices connecting on the same ground of different resistance, creating potential difference. This potential difference can again lead to the floating voltages or the ground loops. These ground loops again can create these sort of issues of voltage buildup. So it's better to always connect it onto the DC ground. So what is the conclusion that we have come up, or the thumb rule that we need to follow, that we need to understand? That the data logger should have its ground connected to earth ground. This is the first thumb rule.
Yes, sir.
Second, each sensor should be reliably connected to a ground to avoid common mode overranging. So common mode overranging was what? Was this. Which is this. Which means the common mode range should not be above the input limit of any sensor. If it is a 0 to 10 volt, then it should not be above 10 volt. If it is 4 to 20 milliamperes, then it should not be above the corresponding voltage conversion of that 0 to 4 to 20 or 0 to 20 milliamperes. Third point is again very important to consider. Each sensor should be grounded at one point only, which means the sensor should not be grounded from this wire here as well separately, and should not be grounded like this here as well separately. Otherwise, this will lead to wrong data always. So why one point? Because we need to avoid ground loops, because on different grounds we might find different potential voltages, potential levels. So to avoid this, we always tend to connect the ground of the inner sensor. I'm not talking about the core, but the inner sensor, always to one point, which is always better to connect on the data logger, because in this way you can ground all the field devices connected in the same chain. In order to achieve a single reliable grounding point for the sensor, it is best to ground the sensor at data logger. This is what I explained. Make sure that the sensor is electrically insulated from all electrically conductive media, your wires, your cables, your inner components. Keep in mind that even a partial connection to the earth by water or by direct burial of any uninsulated sensor can cause a ground loop if the sensor is grounded at the data logger. So I think this part which I tried to explain why grounding is necessary. if you will try to do, this can eliminate at least 50 to 60% of your issues related to communications. Anybody is having any question related to grounding part till that, so that I can then proceed further?
Hello.
Hello?
Hello. Yes, sir. This is Rajeshwar this side.
Yeah.
I have a question from
Yeah.
where this 4 volt it was showing, because the pyrometer we know generally it is not connected to any other device.
Hmm.
It is only connected to the data logger.
Hmm.
So there is no source of having 4 volt there.
That's what I'm saying. It is not only a fixed voltage 4. It could be 5.1, it could be 10, it could be 20, it could be 24 as well.
So what will be the source of that?
The source is the electromagnetic fields, electromagnetic inductions, atmospheric conditions, which has created float voltage inside the system. And further, as I've mentioned, that it is not a overnight thing that happens. It takes few days and few weeks. It might occur in some days or weeks.
So this might be a
It's a
calibration
summation.
issue of the parameter. This will lead to a calibration issue of the parameter.
Exactly. This might lead to a calibration issue of the parameters as well.
Okay, okay. So means once you get the parameter which is showing the variation in the voltage like 4 volt or 6
Yeah.
volt or 10 volt.
Yeah.
So you need to have the calibration done for the parameter also.
Yes.
Plus you need to check the grounding also.
First of all, it's better to check the grounding. Try to do the grounding if the grounding is not there, and then recheck the this voltage as I've shown in the next picture here. If it has come
Yes,
to that within the level, within the specified range of the parameter, then it's okay. Otherwise, you need to go for the calibration.
So means if any electromagnetic field is creating such voltage, it will be grounded.
Exactly.
That's the conclusion.
Exactly. But then this is not again the correct practice. The correct practice is this one, where you have to actually physically connect the data logger ground as well to the ground.
Yeah, like we do for any panel.
Exactly.
Like LT panel or any ECDP.
Exactly.
We do the panel body earth. So it's the body earth basically.
Yes, this is not a body earth. This is a data. This is a data earth. So there is.
No, it's the data logger body, na? The data
No,
logger
that's not data logger body. Data logger body used to be of polycarbonate or a plastic.
Okay, okay.
That's the data itself. That's the data ground.
Okay, okay. It's the data ground. Okay.
Yes.
Got it. Okay, sir. Thank you, sir.
Yeah. Most welcome. Proceeding further with some of the queries that you might already have. Maybe after this, then you can proceed with your further queries if I have not covered in here. For example, some of the Modbus devices in the chain are not communicating. I have connected as per your said wiring, but still I have found out that out of 20 or 30 devices, only 15 or 16 are communicating, but the remaining 14, 15 are not communicating. What could be the reason behind? Your data logger is having some issues or what? Because my wirings are okay. For that, our recommendations are always like to check first of all the Modbus parameter settings of the devices that you have connected. Have you set the common baud rate, common parity, common stop bit, and common data bit to all your devices, be it inverters, meters, sensors on Modbus connectivity? If not, then you need to set them to the common baud rate. If it is 9600, then set 9600 for every device. If it is 19200, set it 19200 for every device. Or if it is even more, then set the same level of baud rate for every device. If the parity is none for any device, set none for every device, or even or odd. But at least a same parity should be there for each and every device connected in the chain. Similarly, the stop bit and data bit should be same, which usually used to be common. The main thing which you can change is the baud rate and parity. So this should be always common on all the devices that you have connected, provided that the serial Modbus address is always unique for each and every device and in the range of 1 to 247. If you have 30 devices, make a practice to set up the address ID of the farthest device as 1 or the nearest device as 1, and then move along subsequently 1, 2, 3, 4, 5, 6 like that. So assign the unique address ID. There should not be 2 devices with the same address ID. Otherwise, you will not find one of the device communicating. So then you can tell it as a name, or you can in a layman tongue, you can you use the word called name, simple name. So the name should not be common for two devices. Naming should be unique, so that any master can identify with the particular name that if I'm calling this name means this device. This name means meter number 1, or this name means meter number 2, or this name means inverter number 10. So address ID for each and every device connected in the chain should be unique and should be in this range. Second question could be like, I have set all these Modbus parameterings, but it's still I've seen that few of the devices have come up, but still a couple of devices are not communicable. What could be the further reason behind? So in that case, then you have to see some more things to cross check. First of all, the field communication cabling for any loose connections. There used to be some internal breakages in the cable which cannot be visible from the outer layers. So you have to always check the continuity from one point to other point, and then from other point to third point. Then check whether the which the important chapter that we have just covered, whether the data logger is properly grounded or not, and then further the field chain is grounded or not. The impedance of the cable that you are using, is it within the range of 120 ohms, or is it more? Unwanted joints should not be there in the communication cables. It's always better if you really need to put up a very fine terminals, not the joints that we used to do with our hands just to extend the length. Any power cable crossing the communication line should not be there. Again, it may lead to the electromagnetic interferences, which in a due course of time can lead to those sort of issues which we have just covered of floating voltages. Data carrying cable conductor getting earth at any point. So the data carrying cable conductor should not be earth. As I said, there will be again two potential differences at the earth level. Termination resistance of 120 ohm is active at both the ends of the chain. If the chain, normally we used to say that you have to put it active on both the ends of the chain if the chain is quite lengthy. In practical terms, we say that ensure that your cable length for RS485 communication is within the range of 850 meters. And last but not the least, daisy chaining. Normally we used to we misinterpret the daisy chaining part, as we used to connect the 3 chains coming from different directions on the same port, and we used to say that okay, it's a daisy chaining. That's not a daisy chaining. I'll explain in the further slides what actually the daisy chaining looks like. Your next question could be, I have mix of multi-brand of inverters on a single site. Can I manage to to communicate with them on a single data logger for communication? The answer is simply yes. It is possible in many ways. So there could be several combinations. Number one could be like if you have mix of Modbus RTU communicable inverters. For example, Delta. Yogisha ji, you have asked a question. I'll answer it this just after this session. So RTU communicable inverters like Delta, SunGrow, or GrowWatt, or K Solar, or XYZ, whatever are your Modbus communication inverters over RTU. So you have mixed brand of inverters. You can connect them in the same chain, keeping in mind that the baud rate, parity, stop bit, and data bit of all the inverters are set to common, and their address IDs are unique from within the range 1 to 247. Then it's possible to manage the multi-band of inverters following Modbus communication on the same logger. If you have mix of Modbus RTU and dedicated protocol-based inverters. Now, what is dedicated protocol? Dedicated protocol inverters are like particular inverters like Refusol or Danfoss or Delta Solivia models, or there are some ABB specific models which follow their own proprietary protocols, which are not following Modbus or which are not following Sunspec Modbus. So those particular inverters, we already have the library of those protocols in Webdyn Sun. And yes, we have dedicated port for these sort of inverters to connect, and we have dedicated port for the Modbus communications to connect in Webdyn Sun. So you can manage these two type of inverters as well. if you have mix of Modbus RTU and Modbus TCP/IP communicable inverters. So both are Modbus, but the physical layer is different. One is in series, one is in parallel. So in RTU, again, as I said, if you have Modbus RTU, you can again have a mix of Modbus RTU inverters. In Modbus TCP/IP as well, you can have a mix of Modbus TCP/IP inverters. For example, you have SunGrow for Modbus RTU or Delta for Modbus RTU and NGTeam or SMA for Modbus TCP/IP. You can still manage all these sort of inverters on a single data logger or any central inverter. If you have mix of Modbus RTU, dedicated protocol, and plus Modbus TCP/IP protocol-based devices, inverters, devices, sensors, whatever, then yes, still it is possible, or any mix of inverters from the above mentioned protocols and arrangement. So you see that this is what is the flexibility, what I tried to mention in very beginning of the introduction, that the data logger, you have one data logger, you are not seeing what capacity I'm going to pick it up, and you know that I'm on that particular plant, I have only this brand of inverter, or you are sure that on this plant I'm going to have multi-brand of inverters. Yes, there are several different ports for Modbus RTU and Modbus TCP/IP. For Modbus TCP/IP, there used to be a dedicated RJ45 Ethernet port, which is again multi-usable for multi-purposes to provide the internet to the data logger and also to communicate with the field devices. And then for Modbus RTU, there is separate port, which is normally termed as RS485. I'll show you the physical connections as well in the pictures in the further slides. Couple of our inverters are replaced due to fault. So it's a practical situation that the plant is running from some months or years, and one or two or three of the inverters or any Modbus device has got faulty. Can they communicate with existing Webdyn data loggers if you have replaced them with the new ones? So since their configuration has changed. Yes, you just need to assign with them, if they are the Modbus inverters, the same baud rate, same parity, and the same address ID that was there of the old ones. So that once they will be configured and they will be properly connected in the chain, they will be automatically detected by the device and will start communicating. If they are proprietary protocol or the dedicated protocol based inverters, then a new discovery has to be launched to discover those new inverters, because it's not Modbus. So discovery does not work similar to Modbus. Discovery is something different thing, which is meant for the dedicated protocol based inverters. So with the discovery, it discovers all the inverters in the chain and it starts communicating. Further question can be, I have multiple sites to manage ranging from few kilowatt peak to megawatt peak. Do I need to consider various different models of Webdyn data loggers based on site capacities? The answer is simply no. Because as I said, that Webdyn's data logger are very well suitable to manage any capacity ranging from few kilowatts to megawatts, and also does not dependent on to number of devices you are going to connect. If these are 5 devices or 10 devices or 20 or 30 or 50 or 60, we have even managed 65 SMA inverters on a single data logger. So it's just a limitation that comes up at the inverter manufacturer design, what they suggest to connect maximum number of inverters in the chain. If tomorrow someone says you can connect 50 inverters of our brand in a single daisy chain for communication, it's possible with Webdyn already. The communication length of the 850 meters, normally in ideal terms, it's 1.2 kilometers when it comes to RS485, but we see that there is a lot of difference between ideal and the practical terms due to atmospheric, due to soiling nature, due to location, due to the coastal areas or non-coastal areas or windy areas. So these atmospheric issues, atmospheric pressure, humidity, these tends to reduce this overall communication distance. On an average, we have kept a safe distance to 850 meters, where it can be on 900 meters, it can in some areas be up to 1 kilometer as well. But the safest distance that we always keep and always recommend is maximum 850 meters of a communication cable. What sort of cable can be best utilized? This I'll again explain further to make the communication better. But if your length is more, So there are two recommendations, either to use two data loggers for two different lengths, which is always better for long-term perspective, or use a repeater, which can double up your length, and then use a data logger. Next question could be, can I manage both generation control, like for DGPV saying where we used to run DG at the minimum designed rating and at the same time we need to utilize the maximum from solar, or if we can also do zero power injection to grid where we don't have net meterings, or the controlled injection to the grid where we don't want to inject above a particular design limit or onto the grids. So is it possible with the same device to control and to monitor? The answer is yes. So Webdyn's exclusively designed controller come data logger, which is Webdyn Sun PM, can very well manage these tasks of monitoring and controlling at the same time. You don't need to have different hardwares, one for monitoring levels, one for controlling, one for something else. Site is operational and power supply is there to Webdyn data logger, but data not available on web portal. Yes, there are 3 different ports to connect on Webdyn Sun PM. You're right. So a site is operational, but power supply is there to the data logger, but still the data is not available on the web portal. And I'm curious why there is something wrong with the data logger. No. What? First of all, there could be, there could be some physical damages, there could be some short circuitings that might happen due to water ingressions, but normally what needs to be checked at first level? This could be for 2 possible reasons. First, that the FTP server is down or the web portal application has gone under some sort of maintenance for due course of time, and that's why you are not able to access to the web portal or the data that is being passed on the web portals. So for this, what you can do is you can check the raw data. If the raw data from the field is at least coming on the servers or not, that can be checked directly over the FTP servers. You can log into your FTP server with the help of free to download applications like FileZilla. FileZilla client specifically. You put in your host, your username and your password of the server, then you will see some data formats. I'll show you how it looks like and how you can check. Second, if the data files are not available on FTP, okay, you have checked, but you have not found the data files for those time frames or those dates on the server, then it means is it still there is any issue with the data logger? Then there could be a concern of the network or the internet connectivity, because if the device is powered on, if the device's lights are blinking, activity light is blinking at least, this means that there has been a network issue, because you can check it with the WAN LED. If the WAN LED is stable or not blinking at all, there used to be a network concern. If it is blinking normally, then it's working with the proper data and proper network availability. So this could be the network issue. In the case of network issue, the data tends to store in the internal memory of the Webdyn Sun, and as soon as the network will be there, it will push the data again in the LIFO format to the servers, and you can have it again on the web portals. This could be the prime view of your FileZilla server. For example, you have this sort of window available. You can put on your host of your web portal, your username, your password assigned, and the port. Port always is 21. For FTP servers, the port always used to be 21. Then connect, it will open up your server details, your server path. Then you can access with your MAC ID of the Webdyn Sun. This is called the MAC ID, which is always unique to each and every Webdyn Suns. Out of thousands, multi-thousands of the Webdyn Suns available across the globe, no one will have the same MAC ID. So it's very unique to a specific device. As you can see on this server, there are several, and each one is having different MAC ID. So you will be having a particular MAC ID assigned by your site name. So you look onto that particular MAC ID, you reach onto your particular month's folder and see the data, if the data is available for those dates and time. This is always your server time, which means in wherever local region you are, this will be your local computer's time, and this will be your GMT time always, because this is the data file created by Webdyn Sun or Webdyn Modbus or Webdyn Sun PM. Here this indicates the MAC ID. This indicates the data file type, that it belongs to Modbus data. This specifies the date, time, date, month, and year, which is 11th of May 2020. And then your time, which says 6 hours, 1 minute in the morning. And this is GMT, which means for India, you have to add 5 hours and 30 minutes. Similarly, for your own countries, you have to add your particular time variation from GMT, which will be obviously this time. As you can see now, this is my server time, which is 11:31. As India is plus 5:30 ahead, so if you will add plus 5:30 to it, you will get this time. So this is how you can see, okay, for this time I'm having the file, for this time, for this time, for this time. Okay, so on servers I'm having the file. But what this file contains, as you can see, the file size. These are zipped files. That's why the file size is of 1 KB almost. If you will unzip, so now I'm unzipping, for example, for you, this first file. If you will unzip this file, as you know that the initial was 1 KB, and now what is the actual size of this file is 4.6 KB. So this is the reason why we always zip. Why Webdyn devices always zip the files, because so that the data transfer rate, data transfer could be easily transferred to the servers even if the network is low, or even if the network is not that stable, and your running cost should be very, very low. If you'll transfer this data file every time, this will be 4 times or 4.5 times more than what it would have been costed for zip data, which was 1 KB. As you can see here, the comparison, packed data file size was 1.0 and unpacked data file size is 4.6. That's why the files are always zipped before they are sent to the servers. Yogeshji, yes, Webdyns are having their own inbuilt storage. For example, in Webdyn Sun and Webdyn Modbus, the inbuilt storage is equivalent to 1.2 GB of CSV files, which can keep your data safe for a few months. Whereas in Webdyn Sun PM, there is an added advantage that in addition to the internal memory, you have the possibility to extend the memory as well with the help of external memory card. And you can, the idea of the memory card is that parallelly, because when you are shifting the data to the servers, at the same time data will get stored in the memory card. So if you want to extract the data locally, you can always extract it from the local memory card. Webdyn's devices, there is no particular limitation on this, because from few seconds normally it is possible, but we never recommend a second. It should be minimum 1 minute. So from 1 minute of the data acquisition, it's possible to go once a day. So that's onto your choice. But at the same time, it depends on to several other factors. For example, the baud rate, the communication speed of your field devices. No, you don't need any software. You just need the extract the memory card, because the data will be in the CSV formats. You just need to have the proper unzip folder and the Excel software, like normal Office Excel, to open up the files. So most welcome. So the point is, like to extract these informations, it's quite easy with the help of memory card. Normally, when we come up to data acquisition time, 1 minute to once a day, it is possible, depending on to what you want. If you really want to go for over 1 minute, it depends on to several other factors at the field level. For example, what is the communication speed? Is it, if you are setting it to 9600 and you have 20 devices connected in the Modbus chain, certainly, and this chain is Modbus RTU, certainly it will give you zeros and zeros only, because most of the devices will not be able to communicate. But if it is at the same time, if it is TCP IP devices, certainly it's possible. If it is RS485, again you have to see if you can fix up the baud rate to maximum, so that the communication can be faster between the devices from the chain to the Datalogger to the master by the time the timeout happens. At the Datalogger level, there is no limitation for this timing. Similarly, the connection time to the server is again configurable. It can be either at the same time. This is what I'm coming on to the point. The saving onto the portal, it could be either synchronized with the data acquisition, That could be from the synchronization from the data acquisition, that as soon as you have acquired the data, it has been processed and it is sent onto the server. Or it could be you have acquired, you have kept the data files, and you are making the connection to the server every hour or every 30 minutes or every 15 minutes or every 20 minutes, like that. So it depends like how often you want to collect the data and how you want to push the data on the servers. Normally, we used to see that the data acquisition is 15 minutes and the data connection is 15 minutes in most of the cases at solar levels. Static IP is necessary. Why? When we used to set up for the device for the data loggers, because whenever we need to troubleshoot, we need to log into the data logger remotely, we are sure of the IPs and we can log in directly with that IP. If the static IP is not available and the dynamic is there, we always have to make a search on the gateway to check which IP latestly has been assigned to the data logger, and then. But Datalogger is flexible to work on both dynamic and static. Static is preferable always. Now, when you open up this CSV, which is unzipped further, you will see this sort of data structure. Yes, so I'll come on to this portal question, sir. As you can see here, this Excel shows again the same thing, which is the MAC ID, data type, date, and the GMT timestamp. Now here you have Modbus address. So this is a formatted version of a CSV, because normally you get a comma separated files. This has been converted from comma separated to columns in the Excel for better clarity. So you see this shows the Modbus address of that particular device. Okay, I'll come with the marks that I have made, which will be easy. As you will see that this is the date and the GMT timestamp of the data when it was recovered. You will see there are several inverters. For example, these are Delta inverters and EM6400NG meter MFM. This specifies to the definition file name that was assigned by our engineers, or maybe by your engineer if you are writing the definition file by yourself for the particular Modbus device based on to its mapping. Then you have the Modbus address. If you will see, this Modbus address for each of the devices will be unique. As you can see, it's 1, it's 2, it's 3, it's 4. So that has to be assigned at the site level, first of all, to the devices. And similarly, based on to that, we can assign it file configuring. Then the number of Modbus parameters that we are reading from each inverter. This could be 50, this could be 20, this could be 100, this could be 200, depending on to what all minimum data is needed. So we are reading here almost like 105 parameters from these inverters and 3 parameters from the energy meter. This is the header row, and this header always confirms, you can link it up with the definition file, that what fourth number header specifies to what is the value, what is the meaning of fourth. It could be like this. For example, this could be a voltage, this could be frequency, this could be current, this could be this and that. But this always specifies in comparison to the dedicated definition file. In this definition file, the parameters are assigned according to the headers. So this, when you integrate on the web portals, you will get to know. Coming on to the point where I try to explain the mix of the inverters. Here you have the mix of the, obviously you have SMA inverters, but the mix of RTU and TCP/IP inverters. If you will see the RTU inverters, the address Modbus mapping is changing. It's unique, 13, 14, 15, 16, 18, like that. But for these inverters, it's common. It's 3, 3, 3. Why it's common? Why it's not changed for these particular inverters? Because they are on TCP/IP. On TCP/IP, even if you are keeping the address ID common, doesn't matter, because in TCP/IP, the inverters or the devices should have unique IP addresses. So here the catch is that the IP addresses should be unique, Addresses doesn't matter when it's TCP/IP communication. And you will see it's a common file where you have TCP information and the RTU information from different models of the SMA inverters only. And here 25 parameters we are reading because its mapping is different. Here 37 parameters we are reading because this inverter's mapping is different. This similar data file that contains data from string monitoring units, some SMUs or the central inverter of Hitachi, for example, and I'll measure meter. So practically it's possible to collect, any sort of, to communicate with any sort of field devices. We should only know what is the communication protocol it's following. Then you see this data. It's very interesting. So this is based on to the network issues where the memory role comes up. This data file consists of 4 datas altogether in a single file from timestamps 115, 130, 145, and 2. This means that from 115, so the last data file available on the server was of 1 a.m. and then after that this file came up after 1 hour. But this file consisted of the missing data from the server because this data was stored in the device due to network issues. And once it has got the network, it has pushed the complete data file on the server. So it consists of the sensors, Modbus sensors, RT1, again the Hitachi inverter, I'll measure. But if you will see, all the data from these 4 time frames is available in this data file. So this was all about the raw data structures. Now when it comes onto the portal, so for the portal, again there is a flexibility that there is no dedicated Webdyn portal for this purpose. Webdyn works in close coordination with its selective European and Indian partners, where we provide the best portal service in combination with our solutions to the customer depending on to their requirements. But if you have your own FTP servers and your own web portal applications, we are happy to push the raw data files like this in zip formats, of course, onto your FTP servers directly, and then you can play with those data files, can extract those data files directly onto your web servers. Coming on to the analytics part from one of our server, this web portal part, what is important normally, the predictions, which are always handy tool based on to the AI, where you have day ahead prediction, you have latest prediction, and then the actual generation. So the day ahead prediction is 24 hours prediction that normally is being given based on to your previously collected data, historical data, your plant's activity, your plant's performance, previous performance, and the meteor data of the next state. Then you might get sort of the alerts on the common dashboard. The format available is CSV, is zipped CSV. So the format is .csv.gz, and you have to unzip it and then use it. So for example, you have got 42 cleaning alerts. If you will click on the cleanings, you will get to know on which sites, through which inverters. So the cleaning alert will be at the inverter level. The string of the modules connected to that particular inverter needs cleaning. The string of the inverters connected to the modules connected to these inverters needs cleaning. String of these modules connected onto these inverters needs cleaning. So generally it alerts, it raises an alert of the cleaning based on two particular inverter levels or the strings connected, depending on to the degradation of the performance from that inverter. This is not a sudden generation. This generation usually occurs after 2 to 3 days of gradual performance degradation, because it at the same time initially checks several other concerns of degradation. If it doesn't find any further concerns, any further issues of the degradation, but is still the performance is degrading, it raises an alert to check the dust accumulation. In CSV, you will always get the raw data. This is the tool, this is the artificial intelligence engine that is being built up on the web portal. So with the help of the data, this engine works. Similarly, like, the gateways level alerts, the Webdyn devices, whether they are disconnected or they are powered off because you are not getting the data, the subsequent tickets are generated. You can check when it was generated, to whom it was generated, to whom the mail was sent for this, when it was sent, and when it is closed, because everything happens automatically normally on these levels. Inverter levels, things again, what are the inverter alarms that is being generated for this inverter disconnected physically, not communicating at all for some time with the data logger. The prediction is dependent on your historical information, historical data collected first of all of let's say minimum 1 month. Plus, your plant should have the radiation or the radiation sensor or the pyranometer installed. Plus, the day ahead meteor data, what it says, what it predicts for your particular geolocation of the site, and then it compares your plant's performance, historical performance, and with the futuristic data, and then this artificial intelligence engine works out and calculates out the prediction for you. Prediction always changes 15 minutes before of the actual time as well, because the data, the meteor data can change. Suddenly the clouds may come up, the wind may come up, the temperature may suddenly go up and down. The prediction is always done at the web portal level, not at the data logger level. Sort of the report, so different web portal types will have different report formats, but normally you get the same sort of vital information available, which you can easily download. This is what is quite of an exclusive report that you always can get via Webdyn Sun or Webdyn Sun PM loggers. With the help of them, normally, because you get the power off and power on alerts dedicatedly from Webdyn Suns to the server, so you can specifically check when the power off happened on your particular site, on which date, at what time, and till what time. So for what duration normally it was there. This tends to, when you really need to present your reports further, that because of this we have suffered the loss of solar generation, so you can claim or whatever are your agreements further. But this can be very handy tool for you to have these sort of reports. This is only possible if you are utilizing Webdyn Sun or Webdyn Sun PM on your site. After discussing all these things, I have flexibility to share report SMS text. Data loggers have the possibility of SMS, but SMS are meant for the diagnostic purposes. When there is no internet connectivity and nobody available on the site, but we still need to check whether the data logger is alive or the site is functioning or not, we can send some SMS commands with some specific big notations, and we can get the particular answer from the data logger itself. But it will not give you the data specifically through SMS, or will not give you the alerts through SMS at the data logger level. But yes, it's possible at the web portal levels, because the alerts or the SMSs or the emails are the web portal functionalities. So what should be the conditions of an efficient monitoring? We have gone through all these site level concerns from the field devices, from the data loggers. So what you should do, first of all, what should be the first aim? The first aim should be to collect and transmit all the needed information in any case and whatever they are. Like, whatever your information you need, you should collect all the mandatory and required data from the field. This means that your device should be capable to not only to read inverters, but also to read number of meters, whatever meters, number of sensors, your string data, your DG meters, your transformer level informations, or whatever field devices you have and you want to monitor. Maybe your dry contacts as well, if your particular circuit breaker is on or if it is tripped. Install the solution following the most reproducible, efficient and clear process. As I've said, that it should be very clear what it is doing, what it is collecting, what it is sending, whether the data is reliable, whether the long-term performance is okay for the setup or not. But at the same time, it should be as simple as possible for the customer, for the site person to understand and handle. Display the data in the smart and relevant interface with the added value depending on the need. So this added value generally comes up from the web portal type, web portal intelligence, whatever sort of intelligence you put in. So that's why you are not bound to use a particular sort of a GUI always with Webdyn. You have the choice of different portal availabilities, or if you have your own portal, you want to save further on the portal paths, you have your own needs created, you can directly get the raw data files and you can work with them. If you need to collect the bare minimum devices from the field to start up monitoring, what you should do. At level 1, if you need to collect, you should always collect the meter, because they will tell you the production levels of your, or the generation level of your plant, and further when your plant started generating and when it stopped. Level 2 of the level 2 data should be, if you can collect normally, which we are doing, is the string level information, or the inverters, string inverters, or the central inverters, alarms, these sort of informations which are quite important for us to understand the plant's behavior. And then for the I'll say 90 to 95% correct analysis of the plant, if you can also add up the sensors, a good level sensors, so that you can know that, okay, on a good sunny day, my product on a rainy day, for example, my production was more than expected, but on a good sunny day, it has not been up to the mark. Like, what could be the reason? There could be several reasons for this. Maybe your MPPT was underperforming at that day, your inverters was underperforming, or maybe the temperature was high but the radiation was low. Just that tend to generate less power from the modules. So there could be several reasons. So if you will have all these informations collected from temperature sensors, from radiations, from wind speeds, from in some cases even for the hygrometry as well, so these can be very vital and useful informations collectively. The reliable installation process is always necessary. For the installation, I have mentioned already in the previous slides that what you really need to consider, not only connecting the wire from the field to the data logger is sufficient, but you really need to consider earthing or the grounding as the integrated part of the installation process. So the person going onto the site should clearly follow the processes being given or being told in the manual or by the Webdyn engineers during that process part. Okay, so just giving you a brief about what we were talking about: Webdyn Sun, Webdyn Sun PM, Webdyn Modbus, what they are, how they look like, what are their basic features. So Webdyn Sun is a gateway that is used to monitor and collect data from a solar plant installations. The gateway brings together on a single unit all the indicators from the inverters, meters, sensors, string monitoring boxes, transformers, numerical relays, DGs, or HT panel data again from the meters, or the your dry inputs, or dry or analog inputs. So particularly, if you will see, this is what normally we used to have a TCP/IP port or a LAN port for the internet connectivity. So you can provide the internet to this data logger by two modes, either via physical LAN or via SIM card, standard SIM card, GSM SIM card specifically. The power provided is 24 volts. So all the Webdyn devices comes up with a specific power supply, which is single phase 50 or 60 hertz to 24 volts DC. You have analog ports, 4 analog ports available. For 5 megawatt plant, one data logger could be enough if the length is within the limit for the communication. And the try contacts. SPDs are always good to utilize, because SPD works as an additional safety device when you are connecting your Modbus devices, for example, in a chain, because from any Modbus device, if it is not connected properly or having fault, it can create surge, and this surge can damage the port of the data logger itself, plus also in reverse, it may damage the sensor or the string monitoring boxes if you have connected. So it's always better to use SPDs, communication SPDs specifically, even if not the power SPD. Yes, this is what, as I said, that you have 4 analog ports, so you can connect 0 to 10 volts or 4 to 20 milliamps based analogic sensors. Pulse meter entries. So initially, if you have the pulse devices which creates the pulses, you can connect them. You have 2 entries for them as well. You have inverter dedicated protocol. So again, coming on to the dedicated protocol inverters which are not Modbus. For example, SMA over RS485, which follows SMA net protocol, not the Modbus in some cases. Some models of Fronius, which were IG models, CACO, Refusol, Schneider's Connectcom inverters, ABB 10 and 12.5 kilowatt rating inverters specifically, they follow Aurora protocols, which were from Power1 and all. These inverters used to connect on the dedicated RS485 port, which is RS485A in a daisy chain manner. Remaining Modbus inverters, there is no name or the no directory for the Modbus inverters that these will be suitable or these will not be. Any Modbus inverter can communicate. Any means any Modbus inverter. Even if it is coming today in the market, and if it follows the Modbus terminology for communication, it is already compatible. So Modbus TCP and Modbus RTU. So this is Modbus RTU. You can connect them in a chain, in a daisy chain manner. I'll come to the daisy chain how it further connects. Data can be transferred onto the server via GPRS or Ethernet connectivity. Data transfer is always zipped to reduce your communication cost, because this will affect your data cost always if the data which you're transferring is on higher. I'll share this PPT once the session is over for you to understand, and if you have further questions, you can always write me up on emails. Webdyn PM, which is a new evaluation, and I'll say the hot product of today. In addition, because it is having as Webdyn Sun the 4 analogic entries. What you see in addition, the ports are detachable. You can disconnect them, you connect the wire easily, and then you connect them here. So in Webdyn Sun, you see that in the initial cases, the screws were inside. You have to open up, you have to connect the wire, and you have to tighten them in here. This is the added advantage that you can detach them and you can attach them directly. Now here you have 3 RS485 ports, 3 serial ports. 3 serial ports as of now can be used for 3 Modbus chains. So if you have 3 chains coming from different directions of 500 meters to 800 meters or 100 meters, but 3 chains coming, you can easily connect these 3 chains separately on the Webdyn PM, which means it can manage 3 daisy chains now. So this is the advancement in terms of monitoring. Plus, it can push the data not only to single server, but to dual FTP servers or MQTT servers. So at the same time, from the field, you can have data onto 2 servers. Further, it is having an inbuilt controller, which is commanded by an executional script enabled. So a script can be written based on to the control logic that we want from this device via Modbus control or via relay control. It follows all the vigorous standards for safety, for working, for operations, for electrical safeties, for health hazards, for CE and for UL to work in US as well. It is having 2 independent LAN ports. These LAN ports doesn't work as a switch, but these LAN ports are having different IP networks, which means it can manage 2 different networks at the same time as well. Plus, you have got this micro SD slot. You can insert in the memory card, and it will start storing the data parallelly on the memory card as well. Webdyn Modbus, which is very smart and small device, but yet very rigid and reliable, because it's just a subset of Webdyn Sun. And usually you can use it on a very economic sites where you have only Modbus communications, for example, your inverters, meters, or sensors with Modbus communication possibility. You don't need other ports and you don't need to spend unnecessarily for these ports, and you are okay to compromise with if you're not getting power off, power on alerts, because it is not having inbuilt battery. But other than that, it can manage your sites, it can manage your data perfectly as Webdyn Sun or Webdyn Sun PM can. So you can have Modbus communication possibility over here for Modbus RTU and Modbus TCP IP. SIM card slot is available here as well on the top, and internet connectivity again through this port can be given to the device as well. So in summary, the working and operation, that remote configuration can be done for these sites either with the help of a local laptop connected with this LAN connectivity, and you have the embedded web page. You can open up with the dedicated URL of each device, which can be changed at the later stage to bring them in any network. Customizable frequency of points. This question was already asked, and I have answered that the frequency point is customizable for the data acquisition and data connection. Then what data you want to choose, because if you will see the Modbus mappings of any Modbus device, inverters, meters, you may find several number of parameters, and you don't need each of them, each of the parameters, because some of the parameters are never going to change in their lifetime. So you might need some selective information, selective data, which we can always choose. You can use any SIM card except Geo. In this, for the Geo, you can use the industrial router, which can SIM-based router, in fact, which can convert the SIM's data to LAN, and the LAN can be connected on the device itself. Power supply failure handled by an embedded battery, storage of data in zip CSV files, and this I have already explained. So most of the things can be done remotely. For example, remote change of parameters and upgrade. So you don't need to visit the site again and again for any new change or new upgrade on the site. This is very important thing to understand, as it was for the. There is no particular time for firmware upgradation. Our team, our R&D keeps on working, keeps on inventing new features, and as soon as they test, they find out, okay, it's a essential feature that we should push in all our working devices. They create a new firmware, and we push it whenever needed. But we don't do normally on every running site like this, and there is no particular time for this push. So for the daisy chaining, how it should actually happen. For example, consider this as a meter or a sensor. You have a chain coming, you have data plus, data minus. You have data plus, data minus connected. You have another chain going out from those same ports, again connecting on the another meter or a sensor, data plus to data plus, data minus to data minus, and like this. Normally what happens is, from here we used to take another chain to another device here. We used to take this to another device here, and we keep on carrying this chain like this. This creates a star network. If we have some device here and we connect like this, but we used to do this in fields because our device cannot be merged in this chain. So it's not a daisy chain, in fact. So daisy chain should be like this. Your device should be coming in the sequence like this. Device ID 1, 2, 3, 4, or whatever has been assigned. Datalogger don't necessarily need to connect Datalogger always in the end. If your architecture doesn't allow Datalogger to connect in the end, Datalogger can be connected at any point in between the chain. So there is no hard and fast rule that you have to connect either at the beginning or at the end of the chain. No. There can be two modes of the daisy chaining. Could be the full duplex, where you have 4 wires, or you have half duplex, which is 2 wire. Normally we used to see half duplex communication in 99.9% of the cases. In inverters, if you have the inverters, in inverters normally we used to have data in and data out, so it's quite easy to understand from where we have to take the chain in and from where we have to take out. But normally in terms of meters and sensors, we don't have data in and data out. We only have one data plus and one data minus port. So you have this sort of arrangement to make in that case, data plus, data minus, and then again a wire going out from the same terminals, data plus and data minus, and connected here. $120 ohm resistance. This was the question initially asked by someone in the very beginning, that how to ensure 120 ohm resistance. In the cables, whenever you are making up a communication or a daisy chain, always remember, if your chain is at least over 200 or 250 meters to put up a 120 ohm resistance at the end and at the very beginning of the chain, so that there should not be any data loss. There should not be any data loss in between. Data loss used to happen because of the voltage losses in the Modbus communication. So to avoid that potential loss, we used to connect additional 120 ohm resistances in parallel to plus and minus at the end and at the beginning. Normally in the inverters, if you will see, they used to have additional dip switch to activate this 120 ohm resistor or to deactivate. But in some inverters, they don't have as well. And meters and sensors, you will never get this. So you have to connect them physically if your last device is meter or sensor, or your first device is meter or sensor. If the Webdyn Sun PM or Webdyn Sun is connected at the end of the line, for example here, then in Webdyn Sun PM specifically, how you can activate this 120 ohm resistance, it's already inbuilt. You have to just put up a jumper between Rx plus and this resistance part, and it will activate the 120 ohm resistance. In Webdyn Sun, the procedure is different. You have to open up the uppercase and you have to just shift the jumpers. But in Webdyn devices, you will always find the 120 ohm resistance possibility there, but you have to activate them either via jumper or outer jumper or via inner jumpers. This is sometimes very necessary to avoid data losses, because you might see that your some of the devices are communicating, but one or two of the devices are randomly communicating but not continuously all the time. This could be because of these issues. The distance, just give me a second, just give me a second. Yes, 120 ohm is required at whatever your end devices are. If the Webdyn is at the end of the chain, then 120 ohm at the Webdyn, but you don't need to connect the resistance physically, because the resistance is inbuilt. You just need to activate it. And at the first device as well. A first device could be your inverter or your meter in the chain. First device means which is the farthest from the Webdyn Sun. Type of a cable. Normally this also plays a very crucial role when it comes to communication part, and we used to sometimes ignore this. What we used to do is we used to use normally Cat6 cables or Cat5 cables for communication, because we have them in our stocks always available. But there are several losses, several issues that these cables tends to create, which we never know. First of all, what should be the cable type we should consider? The cable should be shielded twisted pair cable. Shielded and twisted pair, and shielded part should be grounded at least at the one side of the cable. Impedance of the cable should be 120 ohms, as we always keep. So you have to remember 120 ohms everywhere in terms of cable and in terms of termination resistance. This is the reason why we use 120 ohm termination resistance, because the impedance of the cable is itself 120 ohm. So to nullify that impedance part, to nullify that noise, we used to connect this resistance at both the ends of the cable. Now in this course, what we normally do, I don't know how we connect normally at the site, but I'm sure what we will be doing, we'll be using this core as a data plus, this core as data minus, and this core as additional ground or some supply. But this is a clearly wrong practice that we used to do. When we talk about twisted pair, means in a twist, when the wires are coming, one should be used for data plus and the other should be used for data minus of a particular core. These two cores, if they are unused by any chance, they should be grounded at one point. Or either you can make it with the shield and ground it. But they should not be left idle or open on any of the side. this should not be left ideal or open at any of the site, even if they are unused, because these cables can be a good source to create floating voltage and the back EMF or the electromagnetic inductions even within the shield, and can hamper this data quality. So what is always better is, it's always suggested to use a simple 2-core cable which is shielded and twisted pair instead of using Cat6 or Cat5. Try to avoid as far as it is possible. If not, if you have ample stock of them, then it's always better to ground the unused cores and use data plus and data minus from a single core only. This needs to be taken care with utmost importance during connections, and has to be guided to every site person who is going on the site to lay down the communication cable and to connect the communication devices. Coming on to the Webdyn part, how you can connect and where you can connect. Now you have the daisy chain from inverters, meters, sensors. You have this chain connected and you can connect it onto RS485B. They are Modbus. RS485A will have same sort of structure, but it is dedicated for proprietary protocol based inverters that can be again connected in the same sort of daisy chain. You have dry contacts input, so you can manage 4 dry inputs. You can monitor the status of your dry contacts, BCBs, ACCBs, MCBs, whether they are tripped or they are on remotely. You have 2 relay outputs as well. You can control your plant remotely via the help of SMS commands if you are using a SIM card. You can send a SMS to this SIM card to control, to operate, to close or open these contacts. And similarly, you can have your own sort of automation connected further, either to shut down a particular plant or to sound up a hooter or a buzzer, or to switch on a particular section or to switch off that section, which is easily possible with the help of this. And SMS is a sort of thing which is not network dependent. So even if your network is failed, your SMS might be working if your SIM is SMS enabled. So this is the added feature on this. Coming on to the topologies part on the TCP when it is coming to LAN port. So this LAN port is, as I said, is a multifunctional port. With the help of a 100 Mbps or 10 Mbps switch, you can use it normally for the Modbus slave communication, Modbus TCP IP communication, and also to provide the internet to this device for data transfer if you want to use a local Ethernet or a local LAN or WAN cable. If not, if you have only the Modbus inverters on TCP IP, you can connect them directly or through switch as well. On one hand, you can connect your inverters. No, it doesn't support IPv6. IPv6 are supported by our other range of the models which are not meant for solar applications. It always supports IPv4. And or you can use the SIM card for the internet connectivities. It is also having a possibility to connect RS232. For the grid feedbacks, I'll tell you it comes through the meter. It will be in the Webdyn PM, not in the Webdyn section. For the Modbus, this terminology has been explained already in the previous slide, that how it has to be on this, since it is designed for half and full both. So if you are using half duplex, you have to put up a jumper physically between RX plus and TX plus, which is the port number 18 and 20 here, a physical jumper, and similarly a physical jumper in between 19 and 21, which is the physical ports in here, and connect minus to minus and plus to plus to convert them in half duplex. In full duplex case, obviously no jumper is required because we have 4 wires coming. So TX will be connected to RX, TX minus will be connected to RX plus, and like that. Coming on to Webdyn PM, which is obviously can monitor your field devices like Webdyn. You have 2 Modbus chains or 3 Modbus chains available in 3 serial ports. Here, if for example, if you have a DG PV synchronization requirement as well, you can manage up to 3 DG PV DG sets to monitor or to control. Will require the potential free NO contact from DGs, from respective DGs, to detect whether they are on or they are off on all the 3 points or 1 point, whatever, depending on the number of DGs that you have. And also from the DG side, the DG MFM. which will give us the idea of the load and the DG part that is happening. With the help of this DG MFM, we can set up a particular threshold depending on the DG's rating for 30-35%, and above that the solar will be utilized. And based on to the resultant of the calculation, whatever will be the resultant, if it is a negative or if it is a positive, accordingly the solar inverters will get the command on continuous basis in milliseconds always from Webdyn PM to either generate more or to generate less by certain levels. And this is a dynamic control, it's not a step control. Any question on this controlling part? Because I'm sure that there might be several questions popping up in the mind during to relating to controlling part. The time delay is 100 millisecond at from collecting the command, from collecting the data, processing and sending the commands to the inverters. Further, it depends on to the inverters delay process to take this command and to execute. So always we suggest to put them out at a minimum ramp up and minimum ramp down time so that the execution can be quick. Okay, you can keep on asking. I'll proceed with the slides as well. What is the response rate if we have 10 inverters per chain? As I've said, that the response from our side is always 100 milliseconds and the data is transferred down. That depends if the inverters are TCP/IP or inverters are Modbus in serial. If they are in serial, obviously the data is transferred one by one to every inverter. And in 100 milliseconds it gives it, and then in few milliseconds it gives. So normally in 2 to 3 seconds the command can be transferred to every inverter, and by the time inverters start to go down or go up. If it is Modbus TCP/IP, it's in milliseconds only, because whenever you are giving a command to one inverter, at the same time the command is given to every inverter. So when you are controlling, if you are having TCP/IP inverters, it's always better. If you have RS485 inverters, certainly there will be delay, but it will not be that delay that you cannot manage the controlling. So you can manage 2 to 3 DGs as well in the similar fashion. It is serial transfer and it can be parallel transfer on the TCP/IP as well. Yes, equivalent to smart meter features, because it reads the information, it processes the information inside, it makes the algorithm. It's a script enabled device, and then based on to the outcome, it straight away gives the command. So for this process, it is not dependent on to any server or any web portal part. Whatever commands are being done, whatever decisions are taken at the local levels. Similarly, the same architecture, in this way we can manage the grid, zero injection power to the grid, and we need to collect the information from the load meter, solar inverters. Based on to the load meter, we can set up a particular threshold based on your solar plant's capacity, and with that threshold, if the value is going below or above that threshold, we can start controlling the inverter's power in the similar fashion as we were doing for the DG cases. Or we can manage both at the same time as well. Position in system architecture, how Webdyn and how Webdyn PM is placed, it's almost similar in 90% of the cases. You have inverter-based protocols, you have meters, you have any Modbus device, you have circuit breaker status or relay status to be known, you have sensors with analog entries. All these are being collected and processed in particular data file formats and sent onto the server with the help of internet connectivity or the GPRS. And then you have the web portal applications to view deeper analytics and GUIs. Similarly, in case of Webdyn PM, you have all these protocols possible for communication, and you can push the data, but here there is a catch that you can either push the data onto single server like Webdyn, or you can even push the data to dual servers. In this case, this could be your prime server, this could be your standby server to have the data available all the time. Similarly, it can also have the additional control, which I have explained for the DGPV to manage the electrical grid management. So electrical grid management is the zero power injection to the grid. Or we can in fact read the information directly from the plant PLCs. This PLC could be again your Modbus equipment. If you already have a SCADA installed on big plant and you want to push this information or the selective data For a remote communication, for remote monitoring as well, you can simply connect a Webdyn with your PLC, and we can collect the information from PLC via its provided mapping, and can push the data on the servers for your remote monitoring solution. The web portal screenshots, as I said, that we work with few selective top of the level web portal partners from India, Europe, US, and they also offer the white labeling possibilities depending on to clients' needs. And for example, so you have this sort of portfolio where you can log in, you can have all your plans, you have your dashboard looking like this, initial level informations, generation summary, life event, last 30 days. So these are all widgets. Then your deeper level analytics on device to device level, plant to plant level, your heat maps, your parameter level comparisons, reports, your MPPT level comparisons, again a different partners per web portal view. So this could be like depending on your choice of GUI features, report formats, trending formats. So depending on to this you can select. So basically you are not bound with particular GUI all the time, even if you are happy or not happy with this particular GUI. So you have choice of the web portal applications. Okay, so this was all the end about this particular session. Very few, I'll say very few of our references from energy, from solar metering, from industry, from transport sections. So I'll just quickly like to take your queries if you have any further. Hello. Hello. Anyone having any particular queries so that I can answer before ending up the session? Let me go into the chat box quickly. I can. Anyone's query in the chat box has gone unanswered, can ask me please, because there were several questions, so I cannot see each and every query in the chat box. Hello.
So this Solarpv handles only active power control or reactive power control?
It can do both. It can, I mean, it depends on to what you want. Like depending on to the customer's logic, we can design. So it's a script based. So script can be written for any sort of controlling, provided it's possible in the inverter. Provided it's possible in the inverter to write.
So
Someone has asked me, we have 3 solar plants at 3 locations around 50 to 60 kilometers away. Can we integrate all these plants through this system? No, sir, because the distance is 50 to 60 kilometers, so you have to use 3 different data loggers for this purpose. But yes, you can push the data from these data loggers on the common server, and you can have a common web portal view where you will see all these 3 plants under common login and password. So you can have the summary of these 3 plants, and you can also have the individual monitoring of these 3 plants.
shall I log out?
I think this question was from Mr. Ramesh Singh Chauhan.
Yeah, can you send me the this details so that we can further discuss internally?
Definitely. I'm just leaving my email ID in the chat box. So you can just email me your requirement and I'll share.
all these three plants can have three systems and can then
Yes.
three system can be put in one server.
Yes.
Okay.
And there was another question. There are several. One. I think Mr. Someone has asked from. Okay, the question was like, what is the mode of the sort of scripting in the Webdyn and PM? So the basic is Lua. It's not like a ladder logic in we do in PLCs. It's quite sort of a programming language, specific programming language, like we used to do in C or C++. But that's called Lua format, which can be done by the customers as well if they are having their own development team. It's always better. So it's very flexible. Like it doesn't come up with preloaded script. The scripting can be done totally, depending on your logics.